Hi, thank you. So this is my presentation for today, new ideas and techniques for creating real-time imagery, which is a bit not very precise on what I'm going to talk about. And that's because I don't have one specific subject that I want to talk about. I'm going to be talking about many different things. And that's because, unlike what I do normally, which is focusing on one project and trying to make it look the best I can, for the last year, I have been kind of playing around with different ideas and trying to experiment with as many things as I could, none of which I really developed to the final stage of making it pretty or making a demo out of it or anything. But I was just trying to do as many things as I could. So there was a point where I decided I would make one new shader or experiment every week for a year. And that led me to do 50-something different shaders. Well, in fact, 120 different shaders in a year. And of course, some of them were good. Many of them were bad. Some of them were completely unexpected. I got things I didn't expect to find, and so on. And many of them were failures. So I tried to go through all of those shaders of this last year and pick a few which would be interesting to talk about. And many of those, some of them will be like a bit technical, perhaps. Otherwise, others will be more. I will be talking more about not the techniques, but the things I learned, or small tricks, or realizations that I had during that year. So let's go. Let me stop this guy first. There we go. So these are a bit some of the topics. I tried to group all these tricks and ideas and realizations into categories. So I will be talking about lighting, and then lighting again, and I will explain why twice. And I will be talking about how to paint occlusion, and I will explain what that means. But basically, in a few words, it means that rather than trying to be clever on implementing some ambient occlusion techniques, you can paint it by hand, probably. You will see what I mean and why it makes sense sometimes. I will be talking about texturing or surfacing, as some people call it. Most people here would call it shading. I don't want to call it shading because shading can be also used, as we will see, to do 3D objects or lighting or many other things. So just the process of attaching or adding colors to your objects and textures, I call that surfacing. And then I will talk about animation and modeling, and if I have time, some anti-hacking. So most of the presentation will be about hacking things. I do also sometimes do things which are not hacking, but the real proper thing to do, way to do things, like I would write down equations and solve some things and then apply it, and sometimes it works. So if I have time, I will try to talk about that. And then if we have even more time, I have some random stuff which I couldn't put it in any of these categories. So lighting, these are a bit the topics. Let's go here and start. So most of my presentation is going to happen in this live coding environment. Many of you probably know it already. If not, very quickly, this is a website. It's called Shadart. I made it with my friend Paul Jeremias, who is sitting there. And it's basically a place where you can go, register, and become a user and part of the community, and upload your own shaders and creations and learn what other people are doing and so on. The good thing about this is that it's interactive. Like you can go and break the code, or you can change things as well. And you see the changes immediately. So I don't anymore have to go to a compiler, a framework, and go through that painful process of having to compile and so on and so on. What I like a lot, actually, is that it's not the process of not having to compile. It's more the fact that I can see the changes immediately. So sometimes, even if my compilation time was only a couple of seconds, the fact that the window of your demo gets closed and then opens again with the new results, with the new modifications you made, you don't get to see the A-B difference between the two images. I kind of tend to forget what happened in the previous version of my shader. So in this way, everything happens there and I can see it. So, thank you. Apps. Let's go and talk about lighting, as I wanted to talk about. So this is going to be more things that you probably all know. And I knew all these things before this year of experimentation, but I kind of, after making these 120 shaders, I got to find this kind of formula or way of doing things that really works most of the times. It seems to be pretty consistent and consistently give good results to me. So I'm going to explain it, and then you can use it or not or whatever. So lighting. When I try to do some lighting in my shaders or my demos, I try to start with the key light being that one light which brings most of the lighting and shaping to your objects. And I try to balance everything to that one. And every other light or every other source of coloring comes from secondary lights that I adjust based on this one. So the key light in this case, in an outdoor scene, will be obviously your sun, the sun. And then, again, that brings most of the shaping, right? Still, you have many black areas. And I totally recommend not to try to fill those black areas with an ambient light or a constant color or anything like that. I always try to bring the lights or the colors from directional lights, which bring shape into things. And you will see it in a minute what I mean. So I have this second light, which, it's bringing this a bit of kind of ambient light. This is kind of simulating the sky dome. And I make it normally the complementary color of the key light. So the key light being the sun would probably be a bit like yellow color. And the fill light, in this case, the sky dome, is naturally blue, which is perfect because it's the complementary color of yellow. So there you go here, you have the blue. So that still brings color in these areas. You can see a bit of the rock. It's not enough yet. So then you can bring some third light, which is a backlight. And normally I use this one to fake global illumination, which I don't want to do. But imagine you are somewhere in this area, which is not hit by the sun. Still, there are chances that there is something else around that area, like perhaps these rocks here, which are hit by the sun. And then you would expect to get some light bouncing back from the lit rocks to the shadow area. And of course, that bounce light being bouncing from the light is going to be coming from the opposite direction of the sun. So what I normally do is I have my key light, my sun, coming from a given direction in space, 3D vector, and then I create the second light, which is coming exactly from the opposite direction. I normally make it flat. I kind of cancel the elevation of that light and make it horizontal, but otherwise it's always coming from the opposite direction. And that's a great way to lit shadow areas still bring some shaping. You can see this is a bit lighter than this is, probably is more facing this area than this other thing here. And that's pretty much it. Then I have some other lights here. And so those would be the principles of doing some basic lighting. Speaking of bounce lights, let me close this guy. Not only bouncing lights apply to outdoor scene, you can also do the same for indoor scenes. In this case, I have this piano, which, well, I should say perhaps that those which are not really in context right now, everything you see in this shader, in this viewport here, it's the direct result of running this code, which means this piano doesn't exist as a mesh anywhere. It's not a 3D object that I'm loading or anything. It's somewhere described here in code by a combination of boxes and cylinders and things like that. But coming back to the lighting, let me find it. This is my lighting. Again, you can see it's kind of the same structure. I have a key light, and then I have some bounce lights which have smaller amplitude. So normally the key light, you make it quite big. And notice how actually the amplitude of my key light is way beyond 1.0. And that's because, I will talk about that a bit later, but I try to make things not physically correct, but at least close to physically correct. So normally in the old days, the way I was doing things and the way all of us used to do lighting in demos was like trying to get the images the way we want that. Oh, okay, how would I say it? So let's say you wanted to see something very bright on the screen, you would make your objects bright, and maybe your light's not too bright. So the right way to do it is probably to keep the materials of the objects in a low value and then play with the lights. Well, I will speak about that later. But anyway, so these are the bounce lights, and one of these, and we will discover which one it is as we enable them. One of those bounce lights is going to be responsible for let's try that one, for creating a nice gradient on the walls, light gradient. There you go. So we have this patch of light, which is coming perhaps from a window or a door. And in reality, you would expect this light to bounce around, and the intensity of the bounce would be inversely proportional to the distance, or maybe with a square somewhere in the equation. But it would be diminishing as you go up in the wall or farther from that patch of light. So in that case, you can simply fake it by taking somewhere the position of that pixel, or how high you are in elevation for that pixel you are shading in the wall, and use that as a gradient for lighting. And there you go. You can fake things that way, right? Then I don't know what else I have there. Let's see. OK, there is some extra field light somewhere, and so on and so on. So basically, the message here is that the bounce lights not only apply to outdoor scenes, you can also play with those indoors. Oops, I shouldn't have done that. Go back. There we go. More tricks or techniques or observations that seem to work for me when I do these shaders. Speaking of lighting, let me go a bit further. I think there's a nice spot. And let's wait a bit more. I think I have to wait until 22 seconds, if I remember correctly. Yeah, I think that's the spot. So let's go down to the code. Again, you can see my three lights: key, sky dome, and backlight. I don't always give them consistent namings, but that's what they are. And here you can see my light intensity is 8, 5, and 3, which is way beyond 1.0, which would be white. So I make my lights very high, and then probably the materials are very low in the albedo values. But what I want to talk about is this penumbra area, which so I have some techniques to do soft shadows very quickly, and I will show you that later. But let's for now assume you have some way to do soft shadows, and you were using that to modulate your diffuse lighting, right? This is your diffuse lighting. You multiply by the shadow, which is a scalar. It's a floating point value from 0 to 1, and you have your soft shadows. What you can do instead of just multiplying the color by the shadow value is to colorize the shadow value. So I hope you can see the difference in that projector. Yeah, you can. It really becomes a lot more reddish and saturated. You can do that easily by taking your shadow value and make some POW kind of curve, Photoshop curves to your color gradient. And that brings some red, which might or might not be what you would see in reality. But when you put all the things together, it kind of brings some extra color in there, which overall makes the image prettier, I think. Many of the things I would be talking about, and again, this goes against doing things physically correctly, but still, whenever you have a chance to colorize your signals, that could be a soft shadow, it could be an occlusion signal, it could be whatever, a subsurface signal. If you can add some color into it, that always looks good. Again, speaking quickly about the secondary lights, I have my dome light, which brings some color to the shadow areas. Again, I make it blue, as you can see, which is the opposite of yellow, which is the key light. But still, it looks pretty flat here. So again, adding a backlight brings some extra information there and makes the overall image more believable, I think. What else do I have? Fog, yes, important. Another chance for colorizing your images. As you can see here, this image is probably too much saturated with crazy colors. Oops. But that's funnier than making very desaturated images, I think. But basically, that should do it. So I'm removing all the colors and just leaving the fog color, or the atmospherics, or haze, whatever you want to call it. And you can see that the fog color is not blue, just not a constant blue, right? Normally, in the old school OpenGL API, you would have the fog color, and that's one single color that is applied everywhere. And that's what you would get if you were doing, I guess, that. You would get a constant blue color. Now, when you put that in a real scene like that, it just doesn't work. Yeah, like it's great to have blue colors here, far away from the sun area, but when in this area where you kind of expect the sun to be or some light scattering to happen or whatever, you probably want to blend the fog color with the sky with the sun color, which is indeed that yellow color that I had. So if you put it back, you would see that overall, I think it still looks better, and certainly better than all blue. So this is the fog color. Again, something you wouldn't perhaps expect to do normally, or if you do, maybe you would like to have that by means of using some physically based scattering models or something, but you can just use this color gradient by hand, put it there, and get something that integrates better with the scene. And this is the same. Okay, I was going to speak about color grading, but I'm going to skip that one, I think, and go to the next thing. So this was about lighting. And yeah, some of the advices I would give if anyone was to listen to advices, or this is the things I try to do now all the time, or things I try to avoid. So one of the things is I never, ever do any demo image shader experiment without applying gamma correction, which means that as soon as I have a black screen, before I draw my objects on meshes, or as we call them in the demo scene, cubes, before I put my cubes on the screen, I put a square root in the end of my shader, a square root which kind of mimics this power of 1 over 2.2 color correction curve, or you can add a pow if you want. So really put it there, and only later start tweaking your lights. If you don't have it, you will see everything, it's too dark, you will create very bright ambient lights to compensate, or fill lights, but still the lighting will be wrong, the gradients, the transitions between darks and brights will feel wrong, it won't feel realistic. So put your square root, and then everything else has to be adapted or made after that. Even the post-processing. Before I was never sure if I should apply post-processing as a way to increase the realism and fix all these gradients and transitions things, but I learned that put your gamma curve and use the color grading or post-processing to beautify things, but not to fix the lighting. And I also learned that I think I like to do it after the gamma correction. You can always think, should I desaturate or saturate my colors before the gamma correction? So I'm doing that afterwards, and it seems to be working for me. And yeah, one very important thing, as I said before, never use a constant ambient light. You probably know that since a long time, but I learned it just recently. So if you want to bring light to a given area, put a light source somewhere. Even if it doesn't make any physical sense to have a light source, put it there. It will bring bumps to life, shaping, and so on. And please, please, please never use ambient occlusion or occlusion on your key light. So I know many games do it, sometimes because of technical reasons, like they render everything at once, and then later they do an ambient occlusion pass, and they just have this black and white occlusion image, and then they have the full rendered image. The only thing they can do is to multiply that. And if you don't have any other choice, all right, do it. But when you are doing that, you are multiplying the sunlight and the key light with the occlusion, which is something that doesn't happen in reality, right? You have a point somewhere in space, in the floor, in the ground, on the table, and that point is visible to the sun, or it's not. There is no in-betweens. There is no, right, it can be a penumbra, but you don't have occlusion of objects around it influencing that visibility query. That point is in light or not, is under the light or not. So don't use occlusion with your key light. It really makes everything look video gamey and a bit demo-ish, and it doesn't look real, I think. Okay, more lighting. So what I said before has a lot of tricks which are not real, like colorizing and so on, but still, in terms of values and bounces and so on, and colors, I try to make things more or less realistic, or following physical thinking or process. But these are all tricks that don't have any physical explanation to them, or that these are just tricks which don't follow reality at all, but seems to work. One of them is using envelopes for lighting, and I will explain what that is. So in this case, we have a scene with some, well, they are not trees, but you can imagine there would be trees if this was motion blurred and the camera was moving fast enough, right? This would be blurred, and the brain would think, okay, these are trees. For now, they are just a texture which got stretched up by means of some volumetric ray marching and so on. But the point is that I don't have normals for these trees or these spikes. I don't have a surface that I can extract a normal for, which means I cannot, in principle, do lighting really for this scene, for this geometry. And I will show you in a bit if I find the right spot. Where is this? Main. Maybe this is the place. So let's say I didn't have normals, and I was just picking a constant up-facing normal to do my lighting. That's what you would get, which is much worse than this, I think, where you can see bumps and shapes, and you can kind of sense the shaping of those hills or whatever they are. And so what I'm doing is basically taking the same function which gives you the height of the trees, which is this low, slowly varying, low-frequency noise shape, and using the normals of that shape and putting those normals into the trees or spikes to do the lighting. So basically, that shape doesn't exist really. It's just a signal driving the height of the trees. But overall, it gives you the shape of those hills. So why not to use the normal of that thing to drive the lighting? And that seems to be working. The second trick, which I have here, is fake your normals. I do have this 0.5 constant. So this would be, if I remove that 0.5 constant, this would be what the actual mathematically correct normal or gradient would be for that hill shape. And it's looking okay. You have some lighting there, but if I want to make the lighting more dramatic and make the distinction between brights and darks more extreme, I can multiply the y component of the normal by something small. And that basically, after normalization, so you have a vector pointing in some direction, you take the y, the vertical component, make it lower, and renormalize. So that basically is making all your normals point more to the sides than they do point upwards. So basically, you are creating more bumpy surface to the light than geometrically you have, like what you have geometrically, right? So sometimes, especially when you have boring things like very slowly changing landscapes and things, you can make the images look better by faking the normal and modifying it a little bit. Sometimes, however, you don't have normals at all, and you don't even have these envelopes that you can extract a normal from. You have things like these where, well, you could compute normals, but let's say you don't want to compute normals. Let's say you are making this 280 bytes demo, and that's what it is. And you cannot afford computing gradients and things like that, or you think you can do without. Still, you can do lighting by using math, which I love. So this is Wikipedia. And the question I want to look at is this one, which is saying, so this is what you would do normally in lighting. You would have a function, a distance field, a mesh. You compute a gradient. That's what this triangle means. And that becomes your normal. And then you have some light, which is pointing in a given direction, v. Probably it's normalized. And then you do the dot product between your normal and your light. This is the regular N.L diffuse or Lambert lighting model. Now, this thing, it's a bit of waste of a time because you are computing 3 derivatives to compute this normal, and then you are dotting that with one given direction. It's like you were computing too many derivatives, given that you only are interested on changes on the surface in one direction of the light. So that's what this equation is saying. You can compute just the directional derivative, which in terms of code, it means that rather than taking 4 points to do central differences and extracting a normal, you can just get 2 points, the point where you are at and the point pointing to the light direction. And then you can subtract both. It still gives you a derivative because you are comparing things which are close enough and so on. But it's a directional thing. And it's equivalent to doing a normal and then a dot product. So in this case, when you don't want to spend code and even rendering time, you can use this directional derivative, which translates to one subtraction somewhere. So I'm taking the point where that I'm shading, I take a given direction, I evaluate the function, and then I have to subtract the function at the point I'm shading. But so you need f of x plus epsilon minus f of x, but f of x is 0 because I'm in an isosurface, so I don't even need to compute that one. Anyway, another trick for those who are doing these 4K demos and things like that. This seems, again, it's not only a good thing for file size, it also saves a lot of computations. Again, you are computing you are evaluating twice only your procedural volumetric function rather than 4 times for the gradient and then, 4 times. So when you have an expensive thing like this real-time volumetric ray marching in this crazy volume, again, I don't want to evaluate that volume 4 times per ray marching step so that I can do lighting as I march through the volume. I only want to do it twice instead of 4. So that's a good place to apply this directional derivative trick. Seems to be working fine. And I think that's pretty much, translucency. I will skip that one and go to relativity. And okay, for this one, I should be killed. I should go to hell. And that's because even I don't like this trick, but it was the only way to get this one image released on time. And you can see this tree has some lighting coming from the right. And it's not very obvious in this image, but the lighting here is coming from a completely different direction. So in this case, the key light, the light vector, is changing in space. So I have a blend between 2 different lighting directions. And as the points in the scene get farther in the distance, I'm blending between them. So basically, it's like light was curving in space and finding the right direction to hit objects to make the image look pretty, which again is something you never want to do. But it did the trick. Okay, so enough of lighting and bad things. Painting occlusion. So actually, it's the same image here. So occlusion, as you know, is this signal or this lighting property that we all use these days to increase the realism of games and demos. There are many techniques to get it to work. Normally, people use screen space techniques. When you are doing ray marching, like in this case, we have some extra tools that we can use to get occlusion to be computed very, very quickly. Still, sometimes it's not quick enough for this heavy shader. Like this is already running at 23 FPS. I don't want to make it slower. So you can paint the occlusion by hand. And let me show you what I mean by painting it. First, I have to find it. And if I remember correctly, I did this last night. It should be SUV. All right, so that's my occlusion or ambient occlusion signal. Of course, it's far from being any close to the true ambient occlusion, not even close to what you would get with screen space ambient occlusion. But still, it gives the image a sense of contact shadows between objects. Like there is these mushrooms, which have, you can see that they are in contact with the ground. They are not floating. They are not, or anything like that. So let me. What if I remove the occlusion and show it to you? I think a 0.6 value, it's a good value to keep the overall brightness of the image constant. So this is what you would get without that painted occlusion. And notice how all these mushrooms feel a bit weird. If I put it back, it sort of grounds objects to the ground and to the world and to each other. I have occlusion also painted for the trees and so on. So the fact is that you are building that scenery, you are building the geometry, so you know how far objects are from each other. So you know how much they occlude each other in a way. So the fact that the way we normally do it is we just place the objects everywhere, and then we pretend we don't know anything about them, and we start exploring the occlusion between them. And it's like, hey, I placed the objects, I know where they are, I know where my mushroom is, let's compute the distance to it, and that will give me an occlusion signal, right? So that's a bit the philosophy. To do that, you can paint it by hand, as I did here. You can use also more of the geometrical properties of your objects. In this case, I have that 3D Voronoi or cellular pattern, and my occlusion I have it there. And I think if I paint it on the screen, so that's my occlusion signal, which in this case I didn't paint it. I'm just using the very same Voronoi or procedural patterns that I used to create the geometry. I use those same signals as occlusion. I probably have to pass them through some smooth step or some ramp or remapping or something, but basically the same signals that create geometry, I just can plug them into the occlusion and get something that looks okay, like inside, in the bottom parts of the rocks, everything is dark and so on. I also did something where you can see these spheres, they get darker in the bottom. That's done by hand, by painting it procedurally, taking the Y or vertical position of every pixel, measuring the distance to the bottom plane, and making a gradient, right? But that's what you would get in reality anyway. And the same radially, like the farther you are from one of these spheres, the less occlusion you have. So you can take all those procedural signals, multiply, and build something that looks like occlusion. And again, just to give you a sense of how much that brings for free without having to do screen space, ambient occlusion, or anything. Sorry, let's make it 0.5. So this would be without that fake occlusion. This would be with the occlusion. So it really helps a lot, and it's free, it's there. And of course, you can always combine that one with screen space ambient occlusion or with volumetric occlusion or things like that. This one, I think I will skip it, but basically in things like fractals, the very same math that build the fractals, you can tweak it a little bit, and it can give you a occlusion signal again, and that will quickly show it. I won't spend time with this one, but basically the same math that create the shape create this visibility information for you. Observation. I won't do this one. I won't go through the code, but basically you can see everything on the bottom, on the depth, on the deep parts of the terrain get darker. So this is just a vertical gradient going from black to white that I use to multiply on the lighting. And that's by observation, right? You just expect things on the bottom to be darker. They are less exposed to the sky than they are, than things in the tops are. And lastly, hacking. And in this one, I have to wait a few seconds before OK, there we go. So there is some occlusion going on in this one. Again, I won't go through the code, but you can see this corner gets darker. And that's, again, abusing the fact that you know what you are creating, what geometry you are creating. In this case, I have a voxel, and it's very easy for every voxel to query the surrounding voxels. So for a voxel, I can just say, OK, what's to my right? What's to my left? What's in front of me? And based on this combination of on-off voxels around you, you can pre-compute some gradients that would occlude that given voxel or pixel. So again, by doing a few bit operations and few dot products, you can get some occlusion without having to cast rays or anything. So next thing, that was painting occlusion. Texturing, yes. This is something I've been very happy to learn recently, which is, I mean, this is things that many people have been using for years, and probably many of you as well, but I just discovered that it's super useful. And that's how to do texturing for these things. So again, these are not meshes. I don't have meshes here. I don't have vertices with UVs. So I cannot apply UV mapping or anything. So how to do texturing? Well, as you can imagine, with box mapping, as many people call it, which is projecting 3 textures for every pixel in the X, Y, and Z directions. And then from those 3 texels that you fetch from these 3 projected textures, you pick the one which is better aligned with your normal. So if your surface is pointing that way, and that's where the X projection is coming from, you use that texel. But if your normal is pointing up, and you have this other projection, then you use that texel instead of the other one. You can blend between those ones with some POW functions or something. And once you have this basic box mapped texture, you can start doing it a few times and multiplying each other and things like that. And the trick to make those textures a bit rich is to take advantage of the geometry that you are texturing, like looking for things like thickness and curvature or occlusion, and use that to drive colors. And let me show you what I mean. Curvature is super useful, which means you have again that piano, and you can see. So this is texture with some box mapping, but then you have these areas and the edges which look like they were broken or old, or like the paint went away because of the use of the piano or something. So in that case, okay, let me. First of all, I have to remove the reflections. So that's my curvature signal, which is kind of an occlusion. It's the opposite of occlusion. Normally, occlusion gives you areas of concavity, areas which are occluded to the sky. The curvature you can think as the opposite thing, where it gives you exposure to the environment. So you can see that the edges of the objects get white because of the curvature. And these would be the areas, indeed, which would be more, would have a bigger chance to be touched by humans or broken because of objects around it and so on. So it makes sense to use curvature as a driving signal for age or for things that break and so on. So I can use that signal, which is still very boring. It's a flat uniform signal, but I can multiply it with some noise, and I will copy paste the whole thing here. So you can multiply it with some fractal noise or whatever you want to call it, FBM, and then it gives you a more rich pattern, but still in the areas which are of interest. So in that case, I can get all these cracks and things by making use of the geometry and combine it with the box mapping. For modeling, actually, let me go one back. I think I can explain perhaps thickness. In this one, no, I won't explain this one, sorry. It was too much of a hack. This is basic principles for modeling in this context of ray marching and procedural modeling. In this case, this is very easy, and most of you guys who have been doing 4K intros and demos know this by heart. But the idea is that you start with simple shapes, simple primitives, which have simple mathematical representations like spheres and cylinders and cubes, and then you add displacement to them. In this case, the trees are one cylinder, and the radius of the cylinder gets wider on the base by using this exponential of the height. So that makes a nice connection between the cylinder and the ground. And then you can add noise to that radius, and then everything gets bumpy and organic. So that's the simplest tool for modeling. The other one is repetition, where you, oops, what's going on? There. Repetition means that you model one thing, and remember these things are mathematical shapes, and that means that if you make the domain of the mathematical function periodic, then basically you are making multiple copies of those objects all over space. So you only pay the cost of one mathematical function, one object in your scene. You don't have to use even instance scene or anything. Just make one, repeat the domain, and you get infinite amount of instances. And infinite like in infinite, like in the mathematical sense of the term. And blending. This one I love. So blending, super useful. Actually, let me find another one, which I like better. Blending. So the problem with combining primitives, especially if you were doing like old school computer graphics with POV-ray or something, you had a sphere, you had a cylinder, you could subtract, make a difference between them, but then you would always have these very sharp edges and connection between objects. In this case, I have a sphere, which is the body of the creature, insect, and then I have some sine waves added on top as displacement to create those interesting shapes here. And then I have cylinders for the legs. Again, the cylinders have a sine wave as the radius, so that you have this nice shaping, which reminds you of a muscle or something. But basically, there is a cylinder and a sphere, and they have to get blended together. Still, you don't see any sharp transition there, and that's because we are using a smooth operation. So normally the way you would combine this one, if you were doing regular computer graphics, would be to pick one object or the other. You pick either the cylinder or the sphere. And then you have this, you can see it very well here. It's a very distinct, you have these two distinct surfaces which intersect with each other. You can replace a mean operation which has this discontinuity, right? You have A and B, they cross each other, and then there is a very sharp corner which doesn't have derivatives. You can replace that by almost the same thing, but at that intersection point where the two curves merge, you can make a small valley, a smooth cubic, quadratic shape in this case, and then you have very smooth lighting between them. And not only helps with putting organic things together like legs and bodies, it also helps you create interesting effects like this still very old school looking bridge, but still you have the snow and the bridge connecting nicely to each other. Again, imagine you were doing a game and you had your bridge mesh, and then you had your snow mesh, and it's like, oh, how do we connect them together? You have to go there and model the displacement on the mesh of the snow. It would be a nightmare. But by using this smooth connection between objects, you very easily get the snow to very nicely accumulate on the walls of the bridge. I don't know if I didn't compile. Maybe I'm changing the wrong place. Okay, that's what you would get normally, right? I like the smooth one better. All right, close. And close. Repetition, blending. Oh, animation. I'm so bad at this. Still, I like playing with it. So this is an example where there is these light sources moving around. And because I do have a distance representation of the geometry, because the geometry is coming from a distance formulation of the thing, I don't know. I can know how far every light source is from the actual geometry, from these columns, and I can make them turn around and avoid them, which is still very tricky because this is an implicit animation. I don't know where the particle was the previous frame, so all the movement has to be one formula. And avoiding collisions in a formula is different than avoiding collisions when you have a physics system where you increase positions with velocities and velocities with accelerations, and then you can correct forces to change the direction of things. When you don't have any of those things and you have an f of x, f of time, a function of time, you still have to avoid obstacles. So it's a bit tricky, but you do have at least a sense of where things are in the scene, which helps. Collision and IK. So we got this guy indeed moving around the terrain. The terrain is a distance field, you know where the terrain is in space, so it's easy for the legs to kind of not penetrate the terrain and have the right height. Then you still have the IK going, right? You have these two joints for the legs, and this is a representation of that. But the crazy thing is that this thing doesn't have a CPU counterpart where I compute the movement and the IK, and then I upload the data and the position of the legs to the GPU or anything. This thing exists only on the GPU. There is no multipath, so every pixel of this render computes the full IK for every frame. And then only if that pixel is hitting the leg, we'll get to render that leg, which was positioned based on that IK computation. So it's a weird way to do it, but you can do it. Blending curves. Another trick that I learned a lot, that I learned recently, I have this dolphin. Let me make this smaller so it runs quicker. So the dolphin goes, it makes 5 cycles underwater, 5 undulations, and then jumps over, makes one big one, and then goes down. So these are 2 sine waves with different frequencies, and then I blend between them. Of course, you have some to take care of this, the smoothness of the animation in the blending area, so it's continuous. You have continuous derivatives as well. It doesn't make any shake, any weird thing. But blending shapes is very interesting. And in this example, another abuse of distance field is the fact that the water kind of, the splashes connect with the dolphin, which again, I don't have simulation. I don't have sprites. I cannot simulate anything. So the way to do it is like this plane. So the water is a plane, which gets displaced with some Perlin noise or something. But then every pixel in the water can query through the distance field how far that pixel is from the dolphin. And when that pixel is close enough, given a exponential fall-off or something, that pixel can displace itself in the direction of the dolphin, trying to grab the dolphin. And that makes the water connect with the dolphin and avoids that otherwise very sharp and boring CG computer graphics and video gamey intersection between the plane and the dolphin. So another way to fake physics or things like that. Actually, speaking of faking physics, this is another example of a simulation where every pixel runs the full simulation, not only for the whole frame, but for all the objects in the whole sequence, basically. And I think I'm running out of time, so that should be it, I think. And this is what I wanted to show off and show my math skills with analytic solutions to many things, but maybe for another time. So thank you. Any questions?
Just raise the hand as usual.
Or I can go on and talk for another 10 minutes.
He has a question, but before we do, will you put this online slide online afterwards? So
I can.
Okay.
I can put it online, but it's basically links to the shaders.
No explanation.
There is no explanation on the shaders. So
okay. So people have to work it out.
Did we record it?
Yes.
Yes. Awesome.
So obviously, when is your next release coming out?
Next question? I don't know. I mean, making a shader a week, it's fun. You don't have to worry about what it looks like. If it's making sense with the rest of the scenes in your demo, you don't have to care about design. You don't have to talk to a musician. I don't know. We'll see.
So, anyone? Oh.
Do you have any plans to add multipass or
Yes.
like JavaScript features for animation and stuff for shaders?
No JavaScript editing. We want still to do everything from the GPU, but yeah, we will planning to do some multipass rendering. So not only so you can do multipass effects like motion blur, depth of field, and such, but also for passing information across frames. So you can make a simulation, store it in a texture, and then play it from there, or you can even save the state of a game in a small texture, like a Tetris or a Pac-Man, and make small games with it, which now you cannot. But yeah. On the other hand, not having that has made us create many of these things, like crazy solutions to things that otherwise you wouldn't find or even care about trying to find. There is a guy who made Zelda, the Zelda game. And oh, I don't remember. Yeah, people are doing crazy things.
Could you just repeat what the question was?
The question was if we are planning to add multipass rendering to Shader Toy.
Yeah, we heard that one, but afterwards.
Oh, he was referring to a shader that someone made about Nintendo opening intro something. I don't remember that particular shader. Yeah, but people are doing basically things which look like they have a state in a stateless way by using analytic or implicit functions.
I was just wondering which of these techniques carries through into your production work on big movies, and if you're working a lot in shader language, and what are some of the big differences, or what are the things that you were able to bring to a big production pipeline with hundreds of people? And
that's difficult to answer. I think every studio probably does things in a different way. And even in the same studio, probably people do things in different ways. What I do, I don't know if I can say anything, but basically I do demos at work. Like, I apply a lot of procedural techniques, but I don't take care of everything. I only take care of a few parts, so there is someone else taking over my work and making it look nice and pretty with lighting, and that's a regular way of doing lighting in movies, I guess. I use C++.
So, if
All right.
there's no one else, thank you, Inigo.
Thank you.